The title of this talk is a mouthful. So it's about how to use metadata to future-proof your data stack. There's a lot of terms here, starting with what is the data stack itself. Different folks have different perceptions about what is the data stack. We'll start talking about that. And I'll talk about the importance of metadata or how metadata plays a part in the data stack, whether you're looking at it or not. And then finally, also get into what does it mean to actually be able to leverage your metadata to make it so that it's easier for you to not only keep your data stack running, but also evolve it over time as the use cases change. But first, my background. I've been doing distributed systems and databases for over 20 years here uh, in the Valley, in Silicon Valley, as well as other places. And specifically in the Bay Area here, I worked at Yahoo. This was in the, I guess, the pre-big data days, where we ended up building a SQL query engine to replace Oracle for analytics because Oracle was getting too expensive. And then fast forward to 2008 at Facebook, where the problem was the same, where we went from uh, trying to use Oracle for analytics to now this using like a Hadoop stack to build data infrastructure. So as part of the initial team that built an open source Apache Hive. And I worked on every layer of the data infrastructure stack there, starting from instrumentation, libraries that automatically capture user behavior, irrespective of which part of the product the user was using. Also ended up building workflow schedulers. Also did a couple of interesting projects. One was data anonymization at scale. So this was about trying to anonymize data that was sitting in your in the data warehouse, where we had to anonymize about a petabyte or more of data each day. Then another project I worked on was to take this giant Hadoop cluster that we had in a single data center and split that out into multiple data centers because we couldn't build a data center big enough to hold all the data. So that was a really fun and interesting challenge, where it was deconstructing plane mid-flight and constructing it in different data centers. So that was a lot. The reason I started Datacoral was I spent a bunch of time at Social Capital, which is a VC firm out here in Palo Alto. And I talked to a whole bunch of companies there about their data needs and how they were planning to use their data. And turns out everybody was trying to figure this out. They were trying to hire engineers to be able to even set up their data stack and kind of grow it. And there are some companies who are also trying to figure out what does it even mean to become a data-driven company. And you have probably seen slides like this or these kind of pyramids in other places. So typically companies want to just go from data to value in one step, right? Turns out it's not that easy. You have to take data through its phases. You might have data sitting in multiple sources, so you have to first extract and load that into a central place like a data lake or a data warehouse. And only then can you start truly understanding the data by joining it, aggregating it, and so on in the data warehouse and transforming that data into producing metrics or KPIs for your business. And once you reach a level of understanding of your data, that is when you start getting into more of the ML AI side of things, where you're trying to do more of the predictive analytics. And then ultimately, you'd want to predict or improve business outcomes or improve your products by serving that data back or serving insights back into applications or into production databases so that the product can take. So this data flow that kind of going from bottom to top here, it's the job of a data engineer in the company to be able to kind of set up the stack to support this type of a data flow. But then for a data engineer, the question is how do they pick and choose the appropriate tools to be able to set up this data flow? And This picture that I put out here is something that came out of Andreessen Horowitz's blog called the Emerging Data Infrastructure Architectures. So I won't try to get into a lot of each of the things here. It's a pretty complicated picture. But what you can roughly see is that from left to right is kind of the data flow. But then there are a bunch of choices for each step of this data flow. And turns out these tools that are available at each step, they have made uh, their own choices around what functionality to offer. In many cases, there is overlapping functionality. And in many cases, a lot of these tools like for data ingestion or modeling the data, they have built out their own metadata in terms of how fresh the data is uh, or what is the quality of the data, as well as they have built out or used orchestration tools internally that are not really exposed to the users of these tools. So that means that as a user or as a data engineer who is setting up this kind of a stack, you end up having to switch between multiple tools, with each tool having made its own choices around how do you author stuff, how do you configure connectors, how do you author jobs, how do you deploy them, how do you monitor them. And in some sense, this is like a split brain problem that you have. Each tool is its own little silo. And the only way to try and manage across these tools is by bringing in other tools that whose main job is to consolidate information from each of these tools. So there are a few metadata management tools that are kind of at the bottom here that need to talk to pretty much every tool in the data flow. And this just becomes a lot harder to manage and coordinate as you keep adding more and more tools to your data set. By the way, just want to stop and say that at any given point in time, just let me know if you have any questions. I'd rather this be more interactive. As you can imagine, I've done this kind of presentation multiple times, so I'd love this to be interactive as well. So let me know if you have questions. So to illustrate the point of the complexity itself, I'll just take an example stack. Uh, this is probably something that you all are familiar with. Use a tool like Fivetran to be able to ingest data from multiple tools into a data warehouse like Snowflake. And within Snowflake, you're transforming the data using dbt and then visualizing that data in Looker. Because each of Fivetran, dbt, and Looker are their own set of tools with their choices around metadata and orchestration. To be able to coordinate between these tools, you need a workflow manager like Airflow, which figures out when to run any of the model updates or when to be able to publish data back out into applications. So in order to understand, so I mean, this is a pretty simple picture, right? And clearly, as companies grow, they add more and more such tools. But even with this small set of tools in a single stack, you realize that there is some amount of complexity. But it's very hard to even articulate what that complexity is. So that's why I came up with this uh, framework to understand the data stack. And what I mean by understanding is typically when you're picking tools for your data flow, you're just thinking about the functionality that you need in each of these, in this data flow layer. And like I mentioned, each of the tools provide their own authoring, testing, deploying experiences. And this hidden metadata layer is kind of, or rather each tool has its own metadata layer. But by disambiguating between these three different layers and kind of actually separating them out, you can get a sense for how to even think about the complexity that you have when you bring together a few tools. So in that simple case of your Fivetran, Snowflake, dbt, and Airflow and Looker, if you start describing each of these tools in terms of the choices they have made in each of these layers, you start seeing that there are some gaps. Tools like Fivetran don't really have lineage information. And on the other end, if you look at DBT, it does have lineage information in the sense that the models can depend on each other. But when you're trying to connect Fivetran and DBT through Airflow is just about jobs and tasks. It does not have any notion of lineage, right? So trying to coordinate between them becomes very complex. And this kind of complexity is seen every day by data engineers who are trying to debug problems in their data. So let's say there is a business user who is looking at a Looker dashboard and says, hey, this number doesn't look right. What's going on? Question is what happens at that point. So the business user says, okay, there's a problem. They'll typically inform the analyst who uh, was the one who actually created the dashboard. They look at the dashboard query to see if there's any problem there. If they don't find any problems, then they now hand it off to an analytics engineer whose job it is to build out these DBT models. The analytics engineer is looking at DBT, figuring out if there are any problems within DBT itself. But if they're finding that the data that's coming in from Fivetran is where the problems are, they hand it off to a data engineer. And now it's the job of the data engineer to figure out where exactly the problem might be. So they look at Fivetran, they look at Airflow, and they spend a bunch of time trying to figure out where the problems are. And ultimately, if it's about source systems or whatever, they can kind of hand it off to a DevOps team or some other kind of team within the company. So this whole kind of debug flow, if you will, ends up taking quite a bit of time, as you can imagine. It involves multiple people and they're all operating or they become experts within their tool. And that means that switching between tools becomes harder. So you end up having multiple people who have to manage each of these tools. And of course, the time taken to actually debug like hairy data problems, it could be hours to days or even weeks in some cases. So what we thought was the way to eliminate the complexity is to extract the middle, the hidden metadata layer, and put that outside of all of the tools that are part of the data flow layer. And so this was the key observation that we had, which was that if there is a standardized way of representing the metadata, this is basically about schema and lineage, as well as statistics about how fresh the data is, or if, for example, if some processes there are failures and whatnot. If that information is standardized across multiple tools or multiple steps of the data flow, then you can actually have the orchestration. This is the business logic that figures out what needs to run next in a data pipeline. If that orchestration is driven off of this pipeline metadata that is shared between each of these tools, then the actual data flow layer itself becomes fairly lightweight and straightforward. And there's a bunch of advantages to uh, having this kind of centralized metadata as well. So your authoring flows, if you're trying to either configure connectors or add transformations or even publish data back out into destinations, that entire authoring flow is all operating on that centralized metadata, which then means that it becomes very easy to figure out if you're making changes in one part of your data flow, how the rest of the data flow gets affected. Does that make sense? I want to make sure that uh, this is clear. This is where we have spent quite a bit of time, as you can imagine, both thinking about it and also building the reference implementation. So I talked about these data catalogs or metadata management systems that have been around, like Alation, Colibra, or the newer ones like Data Hub and Amundsen and those guys. They all end up becoming reference data catalogs, right? So they have metadata, but it's a reference metadata, as in you're reading that metadata. It's read only rather. But what we are proposing is more of an operational data catalog, or the metadata being critical to the data flow. As in, the lineage is what is used to determine what needs to run next. It's not that lineage is inferred after the fact, after a data pipeline has run. Does that make sense? So we have inverted the lineage computation from an after the fact kind of read the logs and then figure out how the tables were derived to the way that a pipeline is specified is by declaring the data dependencies. So you end up with a much simpler specification for your data pipelines. It can be completely declarative. It could be fully SQL or no code if it is connectors and you're configuring them. And once it's declared, the orchestration kind of kicks in and it's able to kind of completely handle end-to-end data flows without uh, requiring any additional programming uh, uh, from the data engineer. And having this centralized metadata has other advantages, like if you want to do observability, as in like you want to understand what's going on in your data pipelines, you don't need like a separate observability layer or like a tool to uh, uh, centralize logs or like centralize the status of data in your data pipeline in a separate tool. Instead, you just read off of the pipeline metadata, and that's your kind of single pane of glass. Auditing becomes easier because all changes are going through the same metadata. Even non-obvious things like deploying a data pipeline, as in if you want to make a change to, let's say, one step of your data pipeline, if you have done it enough times, you know that you can't just arbitrarily change the code of a step of a data pipeline. You have to figure out when to do it so that the downstream processing does not get affected. Because the pipeline metadata has that information about what are the downstream processes or what are the downstream steps that are happening for a given uh, kind of step. If you want to make a change to that step, the orchestration can actually determine when the update can also can be propagated to production. So as authors of this data pipeline, when they make changes, they can just kind of push it and know that in production, nothing will break as these changes are uh, going into production. So this becomes like a really powerful way to work with data pipelines where you can in fact have guarantees that nothing will break, at least syntax wise, as you're kind of making changes to the pipeline. Does that make sense? Yes, no?
Yeah, I think so. I do have a question. So say that you wanted to like plug in Fivetran, for example, as a data pipeline. Would the system need context of the metadata that Fivetran would provide beforehand, or how would it know what metadata to gather?
Right. So what I'm describing here is almost like a first principles way of thinking about it, right? So if you were to build it from
Okay.
scratch, how would you build it? That said, if you have a Fivetran, then you can extract all of the metadata from Fivetran, right? And load it into, if there were this metadata layer that's available, then it gets loaded into the pipeline metadata. And the way you do that is more kind of as a loop, right? So every so often you're fetching metadata from Fivetran, which then might end up triggering orchestration, as in which might end up triggering the downstream transformations that need to run. So some of that integration, I think, is already happening. People are working on it kind of piecemeal between different tools. What we are suggesting is that it shouldn't be the case that Fivetran's metadata looks and feels completely different than, let's say, DBT's metadata. It's all kind of batch process, like micro batch process data with tables and schemas. Why is it that they're each maintaining their own? And now you need a third tool that is trying to consolidate them and provide like a single pane of glass, right? So the tricky part that ends up happening when you have DBT and Fivetran is knowing when to run DBT run, right? If, for example, there's some kinds of delays that have happened in Fivetran and the data has not come in, how do you make sure that DBT run doesn't just get kicked off? Also, if I'm changing the model in, in DBT so that I'm joining 5 tables instead of 4, how do I make sure that the 5th table, I wait on the data to get updated on the 5th table before I trigger DBT run? It's not impossible. It's just that you have to now use an Airflow to write sensors to say, okay, now all of these tables are present and hence you can trigger DBT, right? So now it's like, there's already that SQL query that is saying, hey, I'm dependent on these 5 tables. But in addition to writing that query, I'm also having to write business logic in Airflow to set up the dependency graph appropriately. So what we are suggesting is that that should be unnecessary. SQL is already telling you exactly what the data dependencies are. Just infer it. And if the data integrations or the ingest tools are bringing in the data, if they're able to kind of populate this metadata to say, hey, now this table is updated, then there could be an orchestration layer that says, okay, now have all the tables for this particular transformation been updated for this day, let's say, then it can automatically trigger that model, right? And then it starts getting more complicated from there, right? So you may have data coming in every 5 minutes from one source or every hour from another source. Now, when you have to update a model, if I say I want to update the model every hour, you need some coordination, right? So you need to wait for 12 of the 5-minute batches to kind of come in so that I have one full hour worth of data and then 1 hour of another table's data to have come in before I run the join. Otherwise, I have inconsistent data. So all of that business logic of waiting and stuff is now written in Airflow. Does that make sense?
Yeah, thanks. I'll have more questions in a bit, but
Yeah, absolutely. So this is kind of like a conceptual model, right? So there isn't anything out there that just does this. We have just gotten started on this type of an architecture where we started off with this core engine, which is the metadata store, which essentially stores the pipeline metadata, and an orchestration engine that is driven by this metadata store. And because we've been able to build this core engine with like standard interfaces for metadata, we have also been able to build out integrations. So we have built out connectors that are able to read data from multiple sources. These are all serverless microservices, so they are very lightweight. They're able to read data from the source, write it into the destination, and also they're populating information into the metadata layer, right? And then when transformations are built out, similar to DBT models, but we got inspired by the materialized views that databases have, but we generalized that notion. We said that you should be able to build materialized views on top of other materialized views. So that's your kind of similar to DBT models. But those transformations get automatically orchestrated. So when you write a SQL query for a particular transformation that, let's say, runs in Snowflake, we are able to compile that query and figure out what are the tables that that particular query depends on. And also the user can say, okay, I want to get 1 day's worth of data or 1 hour's worth of data in this particular query. Once they declare that, we know, as in our orchestration knows how many batches of data it needs to wait before it triggers the actual transformation itself. So going back to the example of, let's say I'm getting data from MySQL using the CDC connector every 5 minutes, but then Salesforce I'm getting every hour because if I try to do it more frequently, then I hit into API limits. Now, if I have a transformation that is joining data from MySQL and Salesforce, that transformation, you can say, I want to run it every hour. So our orchestration is automatically able to figure out that I want 12 batches because this MySQL is getting updated every 5 minutes, it's coming in batches. So each hour has like 12 5-minute batches. So as this connector is kind of updating the tables in the warehouse batch after batch, like every 5 minutes, only after all the 12 batches have been loaded into or have updated the table in Snowflake, does the orchestration actually trigger the transformation, right? And this can be done without any explicit code that is needed. You can just write a SQL query, and that query gets compiled. The lineage, as in this query depends on these tables with this schedule, as in with if it's an hourly query or whatever. So that information is what is stored in the metadata layer. So every time data comes in, the orchestration engine gets triggered. It's an event loop, the whole architecture. So whenever there's a new batch of data, the orchestration gets triggered. It figures out what are the downstreams of that batch of data, updates the status of each of the downstreams, and if one of the downstreams dependencies are all satisfied, then the orchestration automatically triggers the transformation, and so on, right? So when the transformation runs, it generates an event saying, "Hey, I'm done." And again, the orchestration gets triggered. It figures out what is downstream of that, and so on and so forth. So this just becomes a really lightweight, asynchronous event loop that can scale almost arbitrarily. Does that make sense? So then, because it's the kind of a centralized metadata layer, observing what's happening is very easy. You just look at that one metadata store. There is no accumulation or consolidation of metadata from different tools. They're all operating off the same metadata layer. And also, because the orchestration is driven by the data lineage is also in the metadata. So you can very easily traverse uh, the data lineage graph that automatically gets generated as part of authoring the SQL query. It's not about data lineage getting inferred after the fact. And because we have built it in a completely serverless manner, we have a reasonable security story. All of our software can be deployed in our customer cloud. No data leaves their environment. We can prove that nobody is able to see their data, right? It's not just through compliances, although we have those as well. So this just makes it a lot more uh, uh, simple with a lot fewer moving parts to get an end-to-end data flow. So that is what our customers do. They end up building these end-to-end data flows. They're able to uh, ingest data from multiple sources into a data warehouse, build these transformations both in SQL and Python. For Python, we end up spinning up containers. And once the data is transformed appropriately, all the transformations themselves are running inside of Snowflake. So we don't do the transformations ourselves. We also have connectors that can publish data back out. So people are able to build these end-to-end data pipelines, and they can build it in a declarative way. So they're configuring these connectors, they're no-code connectors. They're writing SQL. If they have to write complicated transformations, they can do it in Python. And of course, they're also configuring connectors to publish data back out. And as soon as they do that authoring, I guess, so they're able to get a waterfall for every table that's in their warehouse. So there's a few things going on here, and I'll talk about it. This view is basically for this table, which is customer churn probability. And this is the waterfall for this table. So there are other views as well where you can view the actual lineage graph. But here in a runtime view, you get a waterfall. You know that this particular transformation depends on two other transformations, which themselves depend on two other tables and all the way to the source. So in one shot, for a given time period, so each of these boxes that you see here, they represent one batch of data that has actually moved through the pipeline. So for each batch, in one shot, you're able to see if there are any problems. And this entire, so this in some sense is your lineage graph, and you're able to traverse this lineage graph when there are errors or when something hasn't run, you know that something, it's waiting on something else that has not happened and so on. So all of that becomes automatically visible uh, to our customers in just in a single pane of glass. So if you have a tool like this, then you end up with, as you can imagine, a much simpler debug cycle. So I just want to illustrate that here. So same kind of notion where, let's say you want to have like a Looker dashboard, but then a Datacoral driven or this metadata first driven approach of building data pipelines. If someone finds a problem in a dashboard, they can inform the analyst who created the dashboard, and that analyst can look at any of the tables that they have used to produce the dashboard or the report. They can just go get a very detailed view of exactly what happened to that table over a period of time. So they can just in one shot figure out exactly where the problem is. So they can either, because a bunch of stuff is kind of no code in terms of ingest, they can directly fix the ingest tools, or if it is SQL queries for transformations, they can go fix the transformations as well. So this just simplifies the whole debug flow. And what this means is that when people are building pipelines and managing them, they don't take up too much of their time. So the proof is basically in the number of different analyses or number of different pipelines that teams are able to build out with Datacoral. And we believe that in any metadata first approach, this is going to happen, where the authoring flow becomes consistent across every step of the pipeline. All of the metadata is available in one place. So observe, like figuring out if something has gone wrong is fairly straightforward. And you can do more and more. Uh, so you can build more and more sophisticated data pipelines by just writing SQL or in a fairly declarative manner. Does that make sense? Cool. So this pretty much kind of covers everything that I wanted to talk about. So the part that I'll end with is that if you have this metadata first approach, the question is, how do you future proof your data stack, right? And our take is that for any new tool that comes in the market, I mean, there'll always be more and more tools that are available. Ideally, if they're able to talk to your metadata directly, then there's no integration cost. So they fit into this, the stack that you already have in a very straightforward manner. But even if that is not the case, once you bring in a new tool and you analyze that tool as to what choices they have made in each of the layers, right? The DevOps tooling layer, the metadata layer, as well as the actual data flow layer, you can figure out what the appropriate integration points should be to your stack. So we just talked about Fivetran. So if you have like a metadata first approach to this, you have a centralized metadata layer. To bring in Fivetran, or if you already have Fivetran, you try to integrate that into your metadata layer. Instead of integrating Fivetran with a bunch of other tools that are out there, you want all of them to integrate to your one metadata. And we have seen this happen, like even our own stack has evolved over time. We have provided different kinds of functionality. but we are able to add them without too much of a hassle because the interfaces for the metadata are the same, right? So that's how we are able to add kind of more complicated use cases around like Python transformations and stuff uh, without really having to change anything else in our system. Does that make sense? Cool. Awesome. So yeah, so thank you so much for taking the time. Like you mentioned, it's hard to get on a Zoom after all the Zoom meetings or before all the Zoom meetings. So really appreciate you guys taking the time. Happy to answer any questions.
Thanks so much, Raghu. Questions? Fitz, sorry, go for it. Interrupt.
I was just going to say, I mean, this is an incredibly cool approach. This is really exciting. To what extent do you think you guys will end up competing with other workflow management tools like Bagster, for example, or Prefect, this new generation that aims to succeed Airflow in some sense?
Yeah, so as you can imagine, each of these tools are built by folks who have been in the industry for a while and like we know about them and stuff. So that's why I've been talking and writing more about this so that we can start this conversation. So it feels like every new orchestration or workflow manager has to figure out how to integrate with every other tool that's out there, right? So the question is, can we make it so that we can extract that metadata layer out, as in the pipeline metadata out, and have, I mean, there are multiple approaches to how, let's say, Dagster does orchestration or how Prefect does orchestration. I think those are different approaches, and they can kind of innovate in that area. But for a customer who wants to use Dagster or Prefect or both for whatever use cases, I shouldn't have to bear the complexity of having to make them talk to each other, right? Or be able to have a single pane of glass. There are tools like Data Hub and Amundsen who have their own data pipelines to fetch all the logs and metadata from each of the different tools. It's kind of this circular thing that we are doing because the tools themselves are not really talking the same language, right, in terms of the metadata.
Yeah, it's something Matt and I have been actually talking about a bit, like sort of the notion of like a central metadata repository or something where I want to get your take on this, where maybe do you envision that there might be some sort of a standard amongst all tools they can just seamlessly talk to each other? Or what do you envision in that area? Because it seems like interoperability is like a very, there's a lot there.
Yeah, I mean, it's all about how do you get started, right? So if you got started with just building an ingestion capability, the metadata layer is basically an implementation detail. Nobody else needs to know about it, right? So what we are suggesting is kind of flipping it on its head and saying, hey, it doesn't matter what functionality you're building. Let's kind of agree on what is the metadata that you'll be working with, right? So and also this is not just capturing metadata and showing it, right? I mean, I think tools like Amundsen Data Hub are pretty good at that. The problem with those types of reference data catalogs is that they go out of date. It's like documentation in code, right? So it's only as good as the amount of manual effort that goes into maintaining it. And it seems like a little bit of a backwards problem that there are engineers who are taking great pains to define the dependencies in these orchestration tools. And then there is another tool that is trying to infer what those engineers did, right? So it's like, why is that, right? So why not make it so that all of how the pipelines are built, if there is like a common open standard. And in fact, after my conversation with Joe, a few others also kind of remarked to me, hey, why doesn't something like this exist in open source, right? So we are noodling on that, and we'll have something to share pretty soon in terms of how just exposing our metadata layer, right? And saying, okay, uh, it works for us, but I'm sure there might be some tweaks that are needed. So once we expose that metadata, and if more folks get excited about that way of kind of building stuff like metadata first, then I think it solves problems to the practitioner, right? I mean, as vendors, we are a vendor. We want our customers to use only our stuff or use all of whatever we provide. But then as a customer, and I've talked to enough of them to kind of know their pain, which is that, hey, you're telling me something that's very similar to what 5 other tools are also saying. But then there are it's like this patchwork, right? So there's overlapping functionality. And as an engineer or as a data architect inside of a company, it's like this Picasso painting, right? So you're trying to have these overlapping patchwork of tools, hoping that you get enough coverage, right? So we are trying to
It's
see if we can.
interesting. Yeah, we've been the book we're writing. We've been diving into a lot of the actually enterprising stuff. Data management, not a sexy topic at all. You want to bore yourself to tears, read the data management book of knowledge. But it's also a fascinating book in that these are all the best practices of data management and stuff you're talking about, right? And what I find, the crux I've had, and I'm glad we're talking about this, is they seem to approach it, data management and data governance and metadata, as if just capture the metadata. You know, you got your business, your operational, your transactional metadata. Just go get it. It's all good. But then you got to store it somewhere.
Right.
And this becomes one of the cruxes too. We're now, okay, I got the metadata, but every time you do that, it's an ad hoc process.
Right.
There's nothing uniform about it. And depending on the types of metadata, especially when you're talking about, you know, business data, for example, transactional, that's all over the place.
Oh yeah, I mean, that's a whole other problem. I think we are only talking about the subset of the analytics problems. Like once you start talking about applications and how data flows between different services and so on, like these individual API calls and stuff, that's a much harder problem, right? So what we are trying to tackle is a data pipeline believe can be declarative.
Thank you.
So the point that I think Joe was kind of making was that each of these things around data governance, like nobody seems to know where to put them in the stack other than just outside kind of looking into the whole thing. How they actually talk, how do each of these things talk to the metadata management management kind of tools is an exercise left to the reader or the implementer, right? Which is like, how do I connect like a Colibra to my real-time analytics or my Alation to my kind of data science platform? Like it's like this combinatorial explosion of kind of integrations that people have to worry about.
Well, I'll tell you where they usually end up with it. I've seen it. It's Excel.
Yeah. Just like project tracking, that's where the metadata goes. Yeah.
Fitz has a question here. Sorry, Fitz, I didn't get this earlier. He says, you might cover this later, but is the metadata store relational, a graph, or something else?
Yeah, so we have, it's a graph structure, right? So at the end of the day, there is a DAG, but the DAG has a whole bunch of annotations to it in terms of what type of processing it is, or like what is the configuration for that processing and so on. But once you have like a reasonable data model that you're working off of, you can use like a key value store if you want to just keep it simple, which is what we have done to some extent. You can have a relational database, or you can have, like if you want to do like entire graph operations, then a graph database makes more sense, right? So the good thing about the way that we have built out our orchestration is that at any given point in time, we are not having to look at the entire graph ever, right? You might have a complicated DAG. The orchestrator or the orchestration engine, it gets triggered only when one of those nodes fires, right, in this complicated DAG. And all it has to do is figure out the neighborhood of that node. In fact, more specifically, just the one level downstream of that node. It doesn't need to think about anything else. A lot of kind of advantages come in when you try to do this. And this is something that nobody really talks about, but it's kind of the bane of the life of data engineers. Used to be ours until we built our own. We started leveraging this stuff too. Is things like reprocessing, doing like backfills, propagating schema changes, right? Or making sure that when there are errors, your data doesn't go bad. That all of these things can actually be orchestrated to go off of the same metadata. So it brings a lot of advantages to how the entire, so that's why I kind of talk about this, the metadata approach supporting the entire kind of DevOps tooling layer, right? So for example, let's say there was a schema change that was detected in the source, right? A column got dropped, right? So now, how do you make sure that you notify the people who have built transformations that depend on that particular column, right? How do you notify them? You need to have the lineage information that's available. Turns out whenever, even the way that, at least the way that the reference implementation that we have built and continuing to improve, the schema change detection is also happening in a loop, in a data event loop as such. So schema change results in a pipeline event, which then the orchestration then figures out, oh, so the schema changed for this table. What are downstream transformations of that particular table? I'm going to now propagate the information that the schema has changed. And now it's up to the transformation or whatever, or that node or that operator to figure out how to deal with that schema change. Same thing with backfills. If I have an incremental data pipeline where there is like, I'm updating tables, right? Like I'm updating one table and then I'm updating the downstream table based on the changes from the first table. Now, for whatever reason, I decide to completely backfill the one table. Now you need to propagate that backfill through this DAG. How and you have different ways of propagating the backfill depending on whether you're doing merges or whether, as in, it's an incremental pipeline versus a snapshot, or like if you're recomputing history all the time, then you don't care, it's fine. So there are a lot of these nuances that really trip up or require a lot of code in your orchestration engine, or like there's a lot of manual effort that's needed while operating a pipeline. A lot of those problems just get completely eliminated because all that metadata or all of that information is flowing through one system.
Yeah, this is really, really cool. I mean, one thing that Joe and I talk about a lot is kind of moving up the stack of data engineering. And to me, if we think about recent history, Airflow was one big step in that, to say, hey, what we really need to be focusing on is not writing so much code to process data, but like orchestrating all these tools we have. At the same time, yeah, Airflow does not do this. And this is a huge step. This is really, really cool.
Thank you. Yeah, so it's, as you can imagine, a lot of these tools that were open source, and I've already dated myself, I guess, is that they're all inspired by tools from before, right? So Airflow is inspired by a tool called DataSwarm that was built and managed by my team at Facebook back in the day. So it's, I think a lot of innovation has happened since that time. I'm talking 8 years ago now, or 9 years ago. But it's like, in some sense, I understand a little bit about the lineage of these tools, right? In terms of people who were at Facebook went elsewhere and built something that was like, because they wanted something that Facebook had, and they decided to open source some of that stuff. Facebook open sourced a bunch, but clearly other companies have open sourced quite a lot of the tools as well. Yeah, prehistory. That's right.
What other questions does the audience have? Well, I have 4 questions. So could this be retrofitted into an existing system?
Yes, it it is going to be a little bit of a meandering path if it's an existing system, which is the case no matter what, right? So if you already have an entire stack, and it's about, do you want to go in this direction? If you want to go in this direction, then yes, you can absolutely do it. You first start off with uh, ingesting the metadata from whatever tools into this kind of central place, but then you have to slowly start. I mean, that already exists, right? So with these tools like Data Hub and Amundsen. But the key part is to make the orchestration be driven by the metadata. So once you have the metadata in one place, then if you have the orchestration that is driven off of the metadata, then you can start building transformations or some small subsets of your pipeline that are now triggered or like run by this data-driven orchestration. And as you're bringing more and more tools, or maybe you can eliminate some tools because you don't need all of the complexity that they bring in, then in those cases you can slowly but surely start replacing it. Like it has happened in our case as well. When somebody uses Datacoral for the first time, it's not like they're building out their entire data pipeline with us. They only use us for ingest. So we produce the events that, and then we have also given these airflow sensors that can work off of the events that we generate, right? In other cases where data, for example, is loaded using tools like Segment, we have written ways in which events can be generated for our orchestration whenever data gets updated in Segment. Whenever rather segment updates data in the warehouse. So we have this kind of two-way integration that's possible. And then once people start seeing the convenience of, hey, I just write my transformation in one place and it'll get automatically orchestrated without me having to write any pipelines, then you start seeing that it's always about the simplest thing gets used the most, right? So that is the direction that we have seen, at least our customers.
Very cool.
Um,
Fitz. Fitz has a question. I'm just going to read it for those who might be watching this after we're done. Fitz asks, do you see a role for MDM, master data management, in the mix? What would it be? How about general data quality tools? Seems like the metadata tracing you're describing would fit well there.
Yeah, absolutely. So these are all great questions. So master data management is more about the semantics of the data, right? So at least in this framing where we're mainly talking about orchestration and kind of building data pipelines, it is up to the analyst to figure out what are conformed dimensions and like what are the meanings of different columns and so on, right? So we can provide uh, the pipeline runtime metadata to the users who want to start adding semantic information to the schemas, if you will, right? Like to tables and columns. What we can guarantee is that the uh, the data lineage and stuff is accurate, because literally the orchestration depends on the data lineage being accurate. So we can, in some sense, kind of propagate descriptions of columns if they're kind of, we don't have that yet, but we only have kind of table level lineage. It's actually fairly straightforward to get column level lineage. We haven't gotten around to it. So we can propagate descriptions of columns from one table to another because we have that lineage information. So we augment the MDM, I guess, efforts inside of a company. We don't offer anything ourselves, right? So at least what little I know is that trying to understand the semantics of the data means that you're parsing the data, you're trying to figure out what are the unique values there and so on. So we don't do that yet. We allow people to do it. I mean, it's just SQL as far as we are concerned. We can orchestrate it for you, but we don't have that specifically anything for MDM. Coming to data quality tools, that is something that we have kind of dipped our toes in. We have made it so that data quality checks can be part of the dependencies for certain processes. So we have a way to insert dependencies as insert as a dependency a data quality check, which is written in SQL, or even as like a Python function, right? So what that means is that the orchestration, as soon as a table is updated, the orchestration triggers the data quality check. And when the data quality check succeeds, then the orchestration knows to trigger the downstream transformations of a particular table, right? And people get like can get pretty sophisticated with that. So you can either have data quality checks that are associated with a table, so that every time the table is updated, the check is run, and all downstream processing of that table can rely on the data quality check. But then you can be more nuanced to say, for these types of transformations, just this lighter weight check is enough. So you can kind of plug and play any which way that you choose. But again, because of our orchestration being like fairly easy to plug and play, the where we have kind of dipped our toes in terms of data quality checks is in our ingest tools. So for example, if you have CDC connectors, we are able to provide data quality checks around like how fresh the data is. So we are able to deal with replica lag. We are able to generate an event only when all data for a given time period or all changes for a given time period have been applied to the destination warehouse. So this is really important for like some of our customers in the finance industry, because they want to do kind of reporting for compliance purposes or whatever, and they're replicating data from their production databases into the data warehouse. So they don't even want to run the report until they know that all of their data for that, all the changes for that day are actually applied to the destination. So we are able to incorporate that into our orchestration. So the way that we look at it is, every time you add a connector, our API basically takes that connector and converts that into the small sub DAG that it then inserts into our kind of metadata layer, and the orchestration just picks it up from there. So our orchestration or our metadata layer forms like a primitive for each of the data flow steps.
Thanks.
Thank you.
Any other questions? Cool. All right. Raghu, this has been great. So thank you very much.
Really great talk. Thanks for taking the time.
Thank you.
Do you want to throw up your last slide, if people want to get a hold of you?
Yeah, absolutely. So I'll share the deck too, so that you can post it.
Awesome.
Cool.
Awesome. This should be fun. I'm very interested to see where this project goes. Spoken before. Love to talk offline sometime too, and see where we could help out. So
Cool.
Awesome. Cool.
Right.
Yeah, we'll leave the. I guess you can stop recording that.